Hey, good Saturday evening to you, and welcome to the Module 10 demo for correlations. This is Shelley, and in this demo, we're going to accomplish two things. First, we want to check the strength of correlations between scores on the sleepiness and associated sensations scale, or total SAS, and the Epworth Sleepiness Scale, which is known as ESS. And secondly, we want to use syntax to assess correlations between the Epworth Sleepiness Scale and each of the individual items that make up the total SAS, which include fatigue, lethargy, tiredness, sleepiness, and energy. But before we get started, in case you haven't been joining me this semester for all of these great videos, let me give you some background. This data set is called sleep.save, and it is an SPSS file from the Julie Pallant book known as the SPSS Survival Manual. And this has been the mainstay of a statistics class I'm taking for my doctoral program at Texas A&M Texarkana this semester. So in case you are or are not familiar with SPSS, there are two views within this data file. This data view gives us data results from a questionnaire. So this is all the data points that were entered, and this variable view kind of sums up the questionnaire so you can see question labels and get a general idea of information asked within a question, along with how the data was measured. So back to the task at hand. To check the strength and direction of linear relationships between two variables, we should use a correlation analysis. In Chapter 11 of Julie Pallant's book, instructions for performing a Pearson's R and a Spearman's Rho are provided step by step to analyze continuous variables, which is what we have in this case. An example research question could be, is there a relationship between scores on the sleepiness and associated sensation scale and the scores on the Epworth sleepiness scale? We need two variables. Either both should be continuous or one continuous and one dichotomous, which has two values. And in this case, both of our variables are continuous. So in the Pallant book, suggestions were made to first create a scatter plot. This can be done, and I will basically quickly walk you through the steps, but not actually do them because I've done them. So this can be done by going to Graphs, Chart Builder, coming down here to Scatter Dot, and you can go through and pick how you like your data represented. And I chose this first one, and then you drag it up here, which is really cool because it gives you a preview of what the data would look like. And then you come over to the variable box and you select which variable you want to be your X and Y axis. So for my Y axis, I chose the Epworth Sleepiness Scale. And for my X axis, I chose the Sleepiness and Association Sensations Scale. And you as a researcher can choose how you want your data represented and which data points you want on which axis, which is really neat. And you as a researcher can also choose, depending on which variables you want to use and how you want your data represented, which type of charts you use. Anyhow, you would go through here and you can mess with your chart appearances and various options and elements of your charts, and you can change and adjust colors and do all kinds of things with it. I'm going to X out and not hit OK because I've already created it. And I will go into my data file. And as you can see, this is the scatter plot that I came up with. Should you need a specific refresher, more than the one I gave you on how to create a scatter plot, it is listed in Chapter 7 of Pallant's book. Looking at this scatter plot, however, we notice a few outliers. Remember, outliers are ones that don't fall within the main cluster of the data. If we were to draw a diagonal line up the vertex this way, starting at 0, 0, it appears that our data is moving in a positive direction from left to right upward. Our data points are not compact, nor are they neatly arranged in a certain direction. So this suggests that a low correlation is occurring. Now we can perform our Pearson's R and our Spearman's Rho test. So coming back over to our data, again, I'll briefly walk you through it, but not actually perform the steps because I've already done it. You would click on Analyze, come to Correlate. Then you would come to, Bivariate. You will move the Epworth Sleepiness Scale and the total SAS variate to the variables box. And I'll show you where it is. It's the Sleepy and Association Sensation Scale. You can see as I hover over it, it says total SAS. You can ignore these ones that are right here because these are actually from the second part of the assignment. But I'm not going to take the time to go through. And remove those and redo them. Under the correlation coefficients, you want to check Pearson, and I went ahead and checked Spearman, so I would have it later. It automatically defaulted to a two-tailed test of significance and flagged the significant correlations. Under options, I went through and checked means and standard deviations, and under missing values, make sure that excludes cases pairwise is checked. Then we're going to click continue, and you would click OK, and you would get a data chart. I'm going to X out because, as I said, I'd already done it. So I'm going to come over here and show you that this was the next thing that would show up. So we'll talk about this for just a minute. These are the data charts you would get. There are detailed directions for conducting this process or this task on page 138 of Pallant's SPSS book. We still need to evaluate our 6 steps of hypothesis testing, but before we go through that, we can evaluate the data that we've generated so far. Looking at our values for N, we see 251 on our sleep and association sensation scale and 255 on our Epworth. But that's actually not a large discrepancy considering the sample size so far for this exercise, so we will go on. Next, we're going to check the relationship between variables, and our coefficient value is 0.292 for Pearson. You can see right here, Pearson correlation. And scrolling down to our Spearman's Rho, we can see 0.304. Both are positive, indicating a positive correlation. Conversely, had they been negative, we would have noted a negative correlation. Next, we will look at the strength of the relationship, and the range for relationship strength runs from -1 to +1. Our Pearson R correlation is 0.292, and this falls in the upper limit of Cohen's small range. It is at the last number or boundary before moving to the medium range. Our Spearman's Rho is 0.304, which is the first number or lowest boundary in the medium range, so the strength is relatively low. Next, we will calculate the coefficient, which is basically squaring your Pearson's correlation. So if we square 0.29, we get 0.0841. And converting that to a percent, we get 8.41%. And if we square the 0.30 in our Spearman's rho, we get 0.09 when converted to a percent, which is 9%. So the variance is roughly 8.5 to 9%, and that's your effect size. Next, we need to assess the significance level using the significance two-tailed information. For both, it is less than 0.001. Notice here, which is less than 0.05. So there is a low significance level. Now, let's talk about our 6 steps to hypothesis testing. We have picked our test. We selected Pearson R and Spearman's rho, and these are both correlation analysis tests when you have 2 continuous variables, as in our case. The next step is to check assumptions. Random sample, and is our sample robust? Having used this data before, we know that this sample is random and our sample is robust. We have to check for independence of observation and make sure that each case is independent of one another. Again, having used this data multiple times this semester, we know that each participant completed the survey independent of one another and that cases are independent. So there is no violation of assumption. Moving on to normality. The sample is robust and scores from both tests can be assumed normally distributed. A new one for us this time is linearity. This is tested through the scatter plot that we made earlier. Referring back, scatter plot. The dots do not fall on any sort of a curve. Scrolling back up and looking at our scatter plot, the shape is slightly irregular and in an upward right positive direction, so this assumption is not violated. The next step is to list our hypotheses. Our null is that P is less than or equal to 0, with P being the population. That means there is no relationship between X and Y between the 2 scores we are comparing. The alternative hypothesis is that P is greater than 0, the population representing P. That means there is some relationship between X and Y. Next, we set the decision rule. If R is in the rare zone, we will reject the null. If R is in the common zone, we will fail to reject the null. So our range is from -1 to +1, and anything between -0.75 and +0.75 is considered the common range. We have to determine our degrees of difference. We have 2 numbers, 251 and 237. So figuring for both numbers, we ended up with 249 and 235. Looking on the chart, it is in the same range for both. So whether you use 237 or 255, you get the same values. We will discuss this more in the interpretation at the end, or step 6. So on to step 5, calculate the statistic. We already did this using SPSS, so we can go ahead and move on to this last step, step 6, interpreting results. Looking at our chart within our book, whether we use an alpha of 0.05, 0.02, or 0.01, it falls within the common zone, so we will fail to reject the null hypothesis. There is a direct relationship between the 2 variables, and the effect size is between 8.5 and 9%. So there is a direct relationship between the sleepy and associated sensation scale and the Epworth sleepiness scale. The second part of this assignment was to run a comparison with each part of the total satisfaction scale figured separately and compare it with the Epworth. So we will scroll down to our output. We followed the same steps earlier, so I'm going to go back to data quickly. And we went to up here to analyze, correlate, bivariate. And this, remember earlier when I was showing you, instead of having the total SAS, remember I showed you total SAS over here and told you that these individual variables were used in the second part. These are what these were. Each of these variables made up the total SAS, but here we removed total SAS and instead inserted each one of the individual variables so we could compare them. Coming back over here, here are each one of the total SAS components or the individual variables that we compared to the Epworth Sleepiness Scale. So the Epworth Sleepiness Scale stayed, and added were the SAS fatigue, the SAS lethargic, the SAS tired, the SAS sleepy, and the SAS lack of energy. You can see descriptive statistics right here for each of these. I followed the same step, excluding cases pairwise, clicked continue and okay. And looking at this chart, we can see means, standard deviation, and numbers all fairly close. Coming to the correlations, we can see that all of the correlations are positive. And we will focus on this column here, comparing the Epworth Sleepiness Scale with each variable. This one right here indicates a perfect correlation, which makes sense because the Epworth Sleepiness Scale has a perfect correlation with itself, the Epworth Sleepiness Scale. So how you read this would be the correlation between the Epworth Sleepiness Scale and SAS fatigue, the Epworth Sleepiness Scale and SAS tired, the Epworth Sleepiness Scale and SAS lethargic, etc. So we can see 0.291, 0.317, 0.223, 0.276, and 0.226. They all fall within Cohen's small range of 0.29 or less, except for SAS tired, which is 0.37, which I calculated the effect sizes for each one using the same method as above. Fatigue was 8.4%, lethargy is 4.8%, tired is 10%, sleepy was 7.8%, lacking energy was 5.3%, and so the highest was tired, which also had the highest effect size. The significance for all of them is less than 0.001, so they all fall in the common zone, and we fail to reject the null on each separate component of the total satisfaction survey. There is definitely a relationship between each variable of the total satisfaction and the Epworth Sleepiness Scale. This concludes our Module 10 demo on correlation, and thank you for joining me.